The products we introduced today, it is the KMbalancer Plus, multifunction vibration analyzer and on-site dynamic balancer. This machine is suitable for vibration monitoring of various rotating machinery, and on-site dynamic balance correction. This is our main installation. Two acceleration sensors. Two cables for vibration sensors. RPM sensor. A gimbal. And a charger. It has a data cable for the device to connect to the computer. There is also a high-precision electronic scale. There are 4 interfaces on the device. From left to right are the USB ports, speed and charging port. The third and fourth are dual-channel sensor connector. The one on the far right is the power supply. Device switch button, long press for 3 seconds. Device boot. Now, let's connect this sensor to the transmission cable. Align the projecting part of the sensor with the groove of the cable. Plug it in. Then tighten the thread. Put the limo port at the other end of the cable. Insert it into channel A of the device. The red dot of the limo port is aligned with the red dot of the device. When pulling out, gently lift the threaded part. Pull it out slowly. Also plug the RPM sensor into the device. Also align the red dot with the red dot. Gently insert. We can start our measurement now. Long press to turn it on. The up, down, left and right on the device are the selection keys. OK is the confirm key. C is the return key. F1 to F5 correspond to different functions of each sub-option. Select the corresponding function according to this option. Now let's introduce the main functions of our KMbalancer II. The first is the point inspection planning function of the machine. After selection, we click the OK to enter. Now it's what we set up before, a temporary inspection. Select from F1 to F5. F5 OK. This is where we set up a detection about the ground. Measurement point 1, completed 1. We can click to be confirmed. Include attributes. Observe the parameters he sets for acquisition. Channel number and WF. Measuring point signal type is velocity. Upper limiting frequency 100 Hz. Lower limiting frequency 1 Hz. Waveform length 1024. That's 1K. It has already collected once, but we can collect it again. Also include make some deletions. Recollect after deletion. There are 3 functions after clicking collect. Return to save and start collection functions respectively. After clicking to start collecting, it can only click the save button after the data is formed. If there is no data, or before the data is collected, the save function is not optional. Now after this data collection, Save function lights up. We can click Save button. Prompt that the save was successful. Now we can go back. It now shows that it has been collected twice. Now we can connect the device to the computer, returning data. This is the machine inspection plan. Now let's go back to the main interface. Perform the second function. Function introduction of acquisition and analysis. The acquisition function mainly has 6 functions. Now we introduce the single channel acquisition function of the device. Click confirm to enter. We can customize. To choose the data types and signal types we test. The data types are WF and total trend. The signal types are acceleration, velocity and displacement. The lower limit frequency is generally set to 2 Hz. Upper limiting frequency, choose according to the actual working conditions on our site. The waveform length is generally selected by default. After selecting, we can click confirm. Usually the waveform length we just set is 4K. Displacement measurement. Signal type, WF. Measurement of upper and lower frequency limits. It is saved with a name consisting of the date and time. After clicking confirm, we can do a WF acquisition. Now we place the sensor on the desktop. Perform a simulation data collection. Also now F2 and F3 are in an optional state. After the waveform appears on the screen, we can click to stop collecting. If we don't click stop collecting, it will do a continuous signal collection work. Now we click stop collecting. We can have the option to save, measure and analysis. The F3 analysis method can be used for SP analysis. There are 3 options for HNWs and WF. The current option is WF. Now we can switch to the spectrum. To observe the spectrum type of the signal just measured. The red and the blue line on the spectrum are the frequency spectrum and its multiple frequency lines. At the same time we can click 1 and 3 of the keyboard. Zoom in and out of the spectrogram. Then click on 4 and 6. Move the spectrum left or right. After a brief review of the data, we can store the data. The save name is also generally the default. The above is a demonstration of single-channel acquisition and analysis. Now go back to the secondary menu. There is a dual-channel analysis. It is consistent with single-channel acquisition, but it is collecting 2 channels at the same time. Need to connect channel B. Connect 2 sensors simultaneously for measurement. Now comes the 4th function of acquisition analysis, overall evaluation. We click OK to enter the overall evaluation. Machine is classified according to the ISO vibration standard, divided into less than 15 kW, 15 kW to 300 kW, 300 kW to 50 MW, and more than 50 MW of machine power. Hierarchical classification. After we choose the corresponding level, we will evaluate it. Devices will be based on ISO 108161. Vibration standards for small machines. Classify machine at 4 levels ABCD. Now comes the fifth function of acquisition analysis, RPM measurement. After clicking OK to enter, we can directly collect and analyze. Our sensor. By cooperating with reflective stickers, every time you pass a reflective sticker, it generates a signal. Now I'm doing analog RPM measurements on my finger. Now we stop collecting. This is the trend change of the RPM we just collected. RPM acquisition. It can provide reference for our future dynamic balance collection, because dynamic balance requires entering the RPM. Now we introduce the third feature of the device. The third major feature is data viewing. There are two types of data that can be viewed. One we collected earlier, the data in route acquisition. One is temporary data that can be selected through F4. It is a data we just collected and analyzed in a single channel. We can check it through the functions of F1 to F5. Delete or view details. Now it's the system settings of the device. After clicking to enter, it has two sub-options, system settings and system information respectively. Let's enter the system settings first. The main functions in the system settings are: the first is the brightness of the screen. We can adjust it from 1s to 6th gear respectively. Choose the appropriate brightness according to our on-site working conditions. And then there's the backlight. Never close. Close in 30 seconds. 1 minute, 2 minutes. 4 gears can be adjusted. We usually choose never to close it. Then automatically shut down. We can set it according to our own usage habits. Or synchronous shutdown. System languages have Chinese and English. Below is the date and time. Can be set. You can also connect to the computer software. Do automatic synchronization. Then we are on the next page, F5. There will be an advanced setting in this menu. Generally, it is the factory default device of our machine. Sensor sensitivity and voltage. It is not recommended that customers adjust it by themselves. Now let's go back to the subdirectory. Select System Information. In the System Information, mainly some basic information about the machine. Serial number, software version, sensor sensitivity, memory usage, battery voltage, battery level, etc. Operating system version. Now we return to the main menu. This is the fifth function of the device communication function. Click Confirm to enter and it has a current hotspot. Because now we have the connected data cable, our device can be wirelessly transmitted. Device connection. Now our device. A wireless hotspot name of LIP2086672 will be generated. We connect it through the computer. The device can be connected. In the advanced settings, the hotspot name can be modified. Now let's introduce the acquisition function of our machine. Now we are going to go into single channel acquisition and analysis. Analysis interface. Click F4 to select Customize. Acquisition parameters. There are time domain waveforms and total value trends. Two acquisition types. Then the signal type has acceleration respectively. 3 types of speed displacement. Now let's choose a speed. You can also set the up and down line frequency. The lower limit frequency we generally set to 2 Hz. Upper frequency, choose according to one speed of our machine. Generally choose 10 times the frequency of conversion. So now we have a 3000 RPM device. We can choose 500 Hz. Waveform length is generally selected by default. After setting these parameters, we can click Confirm to collect. If we need to collect a large number of this type of machine, we can also save properties. Afterwards, you can directly select the corresponding attribute for collection. Now let's click Confirm. This is the name of the measurement definition just now. It takes our waveform length for K-speed and time domain waveform. Up and down line frequency, date and time. To save as a default name. After we click Confirm, the page for collection and analysis appears. Start collecting now. Wait until the value stabilizes. We can click to stop collecting. It's now stable at about 0.15 millimeters per second. We click to stop collecting. Now we can save through F2. Or use other analysis methods according to F3. We save first. The save name is the same as before. Also single channel, 4K speed time domain waveform date time. A default name. We click Save. Then click Analyze Methods. There is a corresponding time domain, spectral and eigenvalue analysis. Inside the eigenvalue is the corresponding peak, peak-to-peak RMS maximum, minimum value and other values. Spectrum in analytical methods, it's the spectrogram we just tested. We through the keyboard. 1, 3 keys to zoom in and out. Adjust left and right through the up, down, left and right keys. Translate left and right with 4 and 6 keys. The red cursor now is a back frequency cursor. We can also choose F4 to switch the variable frequency cursor. Now it is the function of single channel acquisition, and then we come back. There is a two-channel acquisition analysis. This function requires us to connect to sensors. It needs to be in the second port of the sensor, also a vibration sensor. Then set the tracking channel to be consistent. I won't repeat the narrative here. We plug the vibration sensor red dot to red dot into port A. The speed sensor is also plugged into the speed interface with red dots to red dots. Now we do data collection. Speed acquisition first. Confirm whether the reflective sticker is attached to the position. Brightening sticker when passing. If this little light behind the sensor flashes, it proves that the reflective sticker is attached. There will also be values on the screen. You can stop the collection below, then return to the dynamic balance acquisition interface. Now let's create a new measurement definition. There is single-sided and dual-sided dynamic balance on the screen. Let's take one-sided dynamic balance as an example, and the rotational speed of the input simulation table is 3000. Indexing direction. It means, do I add the counterweight in the same direction as the speed or in the opposite direction? Generally, choose the counterweight method in the same direction, any position. It's 360 degrees where I can rotate. Counterweight can be added anywhere. If it is a fixed position, we based on the number of counterweight holes in our simulation table. To enter, our simulation table has 24 holes. Input 24, 0 point offset. It means whether the angle of my first hole is offset. Generally, our default is 0 offset. Here are some basic settings. In the advanced settings, we can choose the type of signal acquisition. It's through the displacement value, acceleration value or speed value to measure. If it is 3000 RPM, our general recommendation is measurement by speed RMS. Then the upper limit frequency is adjusted according to the speed of the device. You can do it within 10 times the frequency of the transfer. This is 3000 RPM. The transfer frequency is 50 Hz. We can set it within 500 Hz. Then the default value of the average point is OK. Now we can start. After that, enter the interface of node name entry. It uses the single-sided dynamic balance datetime as a default value. We directly click to confirm. Now we have reached the first step. Interface for initial vibration measurement. We turn on the simulator. Then click F4 to start collecting. The speed has not reached a stable speed yet. We can wait a moment. Now after the speed stabilizes, we look at the anisotropy of the imbalance, angle and amplitude. Wait, after stabilization, we can click to stop collection. It's now at 183 degrees. It's basically stabilized. We can click to stop collecting. Then proceed directly to the next step. This rotor weighs about 5 kilos. The counterweight radius is 80 millimeters. So we enter this information. One click to calculate. The recommended weight is 0.65 grams. Now we found a small inner angle screw of 0.77 grams. We add in. Enter 0.77 into the weighted size. Generally, the default is that the weighted position is 0 degrees. We don't have to type. We can also say that we input an arbitrary angle. It is recommended not to enter the default. Then we directly click Next. Enter the interface of weight measurement. I'll add the counterweight first. Then preferably when we add counterweights, make a mark in the weighted position with a marker. Convenient for the next step of angle measurement. Now after adding the counterweight, reboot. Open the simulation console. Then click Collect. The second step is heavy vibration. The first step is the initial vibration. Pay attention to the upper left corner. You'll know where we're at. Now the speed has reached the running speed. The vibration angle is basically stable at around 178 degrees. We can hang around a little longer, make it as stable as possible. It's 179 degrees and it's stabilized. Then the value 9.39 is relatively stable. We can click Stop Collecting. We click Next. It will have a prompt. Do you want to remove the plus weight we just had? According to our on-site situation, if it doesn't change, we can click No. However, under normal circumstances, we're going to remove this one. It's heavy. Convenient for the next operation. Now let's click to try planting. Then take down the test weight we just added. After taking it off, now this device will directly produce the result. We need to add a counterweight of 0.27 to the 12th position. Add 1.26 counterweight at the 13th position. We pass electronic scales and weighted screws to configure these two weights. Now we found two suitable weight blocks. Then start counting the counterweight holes. Our simulation table rotates in this direction. We count in the same direction. The default mark just now is 0 holes. 0 and 24 are the same hole. Let's start counting from here. Below is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We add 0.27 grams at the position of 12th holes. Add 1.26 grams in the 13th hole. When assembling heavy, try to install it as firmly as possible because the speed is faster, more dangerous. After tightening, we open the simulation table. Click Next. Perform residual vibration measurements. Click Capture. Now we can see vibrations from the previous 9 points more than millimeters per second, down to 1.45 millimeters per second. If precise balance is needed, the position where the counterweight is required is at 50 degrees, requires 0.36 grams. Now you can click to stop collecting. Then turn off the simulator. Now if precise balance is needed, you need to add another 0.37 grams of weight. We can adjust the counterweight through the toolbox. Click the OK button. It decomposes 0.37 grams at 59 degrees into the 4th hole again. 59 degrees, that's close to 60 degrees. They all correspond to 4 holes. Let's find another counterweight of 0.37 grams. Now we add the counterweight to the 4th hole. Then we start the device. Click Next. Now it's the step towards precise balance. Click Capture. It's now down to less than 1 millimeter per second. Now we can continue to balance again. Keep repeating the previous steps. It's now 0.6. There is still an imbalance of 0.15 grams. Basically, it has reached the allowable value of our device. Then you can click to stop collecting. Click Finish. Then whether to save. Save this data. Then the dynamic balance is complete. Then if we need to do double-sided dynamic balancing, it's the same as single-sided, but it's a two-step process. Dynamic balance on both sides of the two sensors. It is equivalent to making two single sides at the same time. You can try this for yourself. The dynamic balance we just did. We can read it again directly. While reading, if you are not satisfied with what you have done before, we can continue to rebalance. You can also look at the configuration information through F2 and the general overview of the previous dynamic balance. Initial vibration by 6.27 mm per second, down to 0.32 mm per second. This is the complete data. You can upload it to the computer by connecting to the computer. Initial vibration analysis and dynamic balance report.
KM Instrument.